The majestic sight of Mount Fuji is a well-known tourist attraction in Japan. It's also one of 111 active volcanoes in the country. For geophysicist Dr. Graziella Caprarelli, working in Japan was a rich cultural and scientific experience. Born in Italy, she moved to Japan on a postdoctoral fellowship in 1990.
Japan, as well as Italy, are very active volcanic zones because they are at the margin of tectonic plates. So there are high levels of seismicity and volcanic activity as well. So it is important to study the evolution of those margins, also in order to evaluate volcanic risk.
After spending almost 5 years in Japan, Dr. Caprarelli moved to Australia and was elected as the inaugural president of the Japan Society for the Promotion of Science Alumni Association in Australia to promote the benefits of collaborating with Japan to other researchers.
Australians are highly productive. They have a great record of high-impact research in all of the areas of science. Japan is certainly a world power in scientific knowledge. It has great technology, great equipment, and so it's basically a great marriage.
And for more than 50 years, collaboration between the Australian Academy of Science and the Japan Society for the Promotion of Science has involved thousands of researchers and many Nobel laureates, including Professor Brian Schmidt, who first visited in 1999.
It was a really formative time for me and a great chance to help build collaborations that last to this day. Just had a big Nature paper last year that was built on that trip in 1999, interestingly enough, and it came to fruition 23 years later.
Associate Professor James Sullivan has also been collaborating with scientists in Japan for more than 20 years. In 2001, he did a postdoctoral fellowship for 2 years, researching atomic and molecular physics at a synchrotron in Japan.
It's a big electron accelerator, and you use the light to look at the way electrons in atoms rearrange themselves and gain insight into the fundamental quantum mechanics that goes on that governs those interactions.
His research now focuses on understanding quantum physics and antimatter, which he hopes will lead to advancements in medical imaging technology. And Associate Professor Sullivan is returning to Japan in September 2022 to undertake a fellowship at Tokyo University of Science.
Collaboration's critical. You can't just look up a textbook to tell you what to do when you're working right at the cutting edge of science and technology. So being able to discuss those ideas with other experienced people, use their experience with yours to develop new ideas is absolutely the key to doing excellent research.
Good afternoon. Thank you for joining us today in the first online event in the series, Cutting Edge Solutions to Shared Challenges. I am Frances Separovic, Foreign Secretary of the Australian Academy of Science, and I'll be your MC today. Before we begin, I wish to acknowledge and pay my respects to the traditional owners and elders, past and present, of the land in which the Academy's office is located, the Ngunnawal people, and to the traditional owners of all the lands on which the Academy operates and its fellows live and work. I extend this acknowledgement to all First Nation peoples around the world as custodians of knowledge, critical to understanding our world and informing our decisions. The Australian Academy of Science and the Australian Department of Industry, Science and Resources have partnered to deliver this online series. Today, the first event in the series, we will hear from experts in Australia and Japan as they share case studies of cutting-edge AI and robotics solutions to address some of society's toughest challenges. At the end of the discussion, there will also be time for an audience Q&A. You can scan the QR code on the screen to submit your questions. Please join me in warmly welcoming today's expert panellists. Dr. Keiko Homma, Senior Researcher, National Institute of Advanced Industrial Science and Technology, Japan, Professor Hiroshi Ishiguro, Director, Intelligent Robotics Laboratory, Graduate School of Engineering Science, Osaka University, Japan, Professor Michael Milford, Joint Director of Queensland University Technologies Centre for Robotics, Australia, and Dr. Nicole Robertson, Research Fellow at Monash Data Futures Institute, Australia. Welcome. But before we dive into the discussions, let's hear from the Charge d'Affaires of the Australian Embassy in Japan, Peter Roberts. Welcome, Peter.
Good afternoon, everyone. Minasan konnichiwa. I'm Peter Roberts, the Australian Charge d'Affaires at the Australian Embassy in Tokyo. Welcome to today's AI and Robotics online event, part one of a two-part series on cutting-edge solutions to shared challenges. This online event couldn't have come at a better time for Australia-Japan relations. Our Prime Ministers have met 4 times since Prime Minister Albanese took office in May, and we've also recently hosted visits to Japan by the Trade Minister and the Resources Minister. During Prime Minister Kishida's recent visit to Perth, Australia and Japan reaffirmed that we will cooperate in security, defence, resources and energy. And of course, bilateral collaboration is expanding into new cutting-edge science and technology areas, including space, AI and robotics. This event, organised by the Australian Academy of Science with support from the Department of Industry, Science and Resources, aims to put a spotlight on experts in these fields and to promote research collaboration between Australia and Japan. As members of the Global Partnership on Artificial Intelligence, Australia and Japan are already working internationally on the responsible use of AI. Japan's a global leader in AI-related simulation, human-computer interaction and control theory research, while Australia, of course, excels in theoretical computer science and linguistics. We can leverage these strengths through joint research. Australia supports a range of unilateral competitive research projects, exchanges and fellowship programs. Grants are offered through the Australian Research Council, and these are open to international researchers, provided you apply through an eligible Australian institution. Cooperative Research Centre grants administered by the Department of Industry, Science and Resources provide further opportunities for collaboration by international partners. Individuals and organisations who are looking to collaborate with Australia need to find a suitable Australian collaborator first. Our great educational institutions like the Academy of Science run special events and programs that also promote international research and collaboration. Embracing science and technology and working together is critical to economic growth and to how our society develops. It will allow researchers and innovators to develop solutions to the challenges currently facing our world. I hope you find real value in today's event and the excellent discussion that is coming up. Thank you.
Thank you, Peter. This is a two-way relationship. So now let's hear from Minister Akihiko Tsunami of the Japanese Embassy in Australia. Welcome, Minister Tsunami.
Good morning. Professor Chinupati Jagadish, Professor Francis Separovic, distinguished panelists and guests, ladies and gentlemen. First of all, on behalf of the Japanese government, allow me to congratulate the Australian Academy of Science and the Department of Industry on the convening of today's online event. I also understand that the Embassy of Australia in Japan has also been pivotal in securing the attendance of Japanese top experts in this event. Thank you very much. The holding of this event, cutting-edge solutions to shared challenges, cannot be timelier. Last month, in Perth, there was a meeting between Prime Minister Kishida and Prime Minister Albanese and 2 koalas, as you might remember. Prime Minister Albanese was apparently more of an expert in cuddling these surprisingly large, heavy-looking creatures, and Prime Minister Kishida most probably made some improvement while in Perth. I have not been briefed on the exact comments made by either of the two fluffy creatures during the meeting, and I guess they could be classified. The two leaders, nevertheless, did manage to have some time to have a conversation on a range of topics in the absence of the koalas. While they discussed the importance of the time-tested partnership between the two countries, including what we often refer to as complementary economic relationship. And a lot has been reported on energy and security cooperation. One important takeaway from the Perth meeting is that the two leaders discussed future shared challenges and the way forward. The breadth of challenges mentioned by the leaders is quite extensive: health, climate, energy transition, space, critical and emerging technologies, cybersecurity, disaster management, supply chain resilience, and the list goes on. And do we need cutting-edge solutions to meet these challenges? The potential of Japan and Australia to work together on cutting-edge solutions, be it AI and robotics, or health, including in RNA vaccines, may have been somewhat underestimated or overlooked by many. However, when we look at the quality of research and development in both countries in these cutting-edge areas, together with the increasingly active partnership between our businesses and academic communities, as well as the actual achievements of bilateral cooperation to date, including very well-known examples in the area of space exploration, but definitely not limited to that. Cutting-edge solutions should be one of the defining features of Japan and Australia's collaboration in future. Let me conclude once again by expressing our gratitude to all of you and our conviction that today's event will be another important springboard for our two countries' partnership in science and technology, going from strength to strength. Thank you very much.
Thank you, Minister, for that warm message. We certainly enjoyed watching the meeting between our two Prime Ministers and our iconic fluffy creatures also. Without further ado, I'd like to start the discussion by asking two of our panellists, Keiko and Michael, to give a very brief explanation of the terms AI and robot in the way you work with them, acknowledging that they often have fuzzy definitions that evolve over time. Keiko, Michael?
Yes, firstly, thank you for inviting me to this such a previous event. And well, actually, ISO, so International Standard Organization, has already provided the definition of robots, but I rather take the definition by Japanese groups in 2006. So that means intelligent mechanical systems incorporating sensor, controller, and actuator. And so as we have so ears and eyes and as a sensor, and brain as a controller, and hand and limbs as a actuator. That is, well, I think a simple and intuitive definition of robots. So I'll take this as an explanation of robots from myself. And regarding AI, well, I'm still studying about the AI, but in my understanding, so the program that provides rules and patterns instead of calculating the results directly from the input. That is my understanding on AI so far.
Thank you. Michael?
Thanks, Keiko, for those definitions. I'm also grateful to be on the call. Seeing Hiroshi again made me a little nostalgic. The last time I was in Japan was with Hiroshi in beautiful Nara, so it's great to see you again. AI, as you said, the definitions are fuzzy, but I would define artificial intelligence as some level of automated algorithms or software that does a task that would normally require some level of human cognitive capability, but doesn't require the person to be involved anymore. It could be embodied, so it could be deployed on a machine or a robot, or it could just occur in the cloud. In terms of robots, building on Keiko's definition, the way I like to think about it, and many others, is a robot is a machine that perceives the world, thinks about the world, reasons about the world, and then acts in some sort of physical manner. Now, if you take that strictly speaking, you might think an air conditioner or a washing machine is a robot. And so we add a sort of fuzzy addendum to that, which is the sort of mechanical and physical interaction with the environment has to be substantial.
Thank you. What do each of you see as the biggest societal challenges currently faced by Japan and Australia? And which of these challenges do you think AI and robotics are particularly suited to addressing? Perhaps if we could hear briefly from each of you, I'll start with Nicole. Thank you, Nicole.
Yes, of course. Thank you so much. Happy to be here and on the call to talk about this. It's definitely a very important issue that's coming up in our time. So robotics has a fantastic opportunity to help support real-world physical tasks that may not have been achieved before that advancement in robotics. So in one area, labor shortages, or where there is a need to provide more physical support, robots have the opportunity to very much excel in this space. And we've seen over the past couple of years, there's a lot more robotic machinery that's now being deployed in real world spaces to be able to help different types of tasks. And one area that I have worked in from having co-founded a startup is looking at labor shortages in the agricultural settings, and that there's been scarcity and turnover in the workforce that's causing trouble in the food supply chain and contributing to quite a lot of food waste and making it harder to get fresh fruits and vegetables as a consumer. And this is one area that robots have been supporting for quite some time and will likely have a very big impact in future as well.
Especially now during post-COVID times as well. So Hiroshi.
Yes, well, first of all, thank you very much for inviting me to the conference. And this is my great honor to talk with the Australian researchers. So my answer is, well, it's very similar to the Nicole. And I think, we need to use our robot technologies for the labor shortage problems. And especially after the COVID, I think, we're going to have a more telework, and but this kind of a Zoom conference is not perfect. We need to have a much better systems. So these 2 years, I'm focusing on the avatar technologies. So actually, Japanese cabinet running the very big scientific project is called the Moonshot, and I'm a project manager of the first goal. First goal is to develop the avatar societies by 2050s. That is a very ambitious goal, but we need to achieve that, right? And under this COVID, so our activities are quite limited, but if we have a remote control robot, remote control computer graphics avatars, then we can extend our activities very much, right? And then this kind of a technology that can help the elderly and handicapped people very much, and everybody can walk anytime and from anywhere. So we need to have this kind of the avatar technologies, and how we can build the avatars, robot avatar and computer graphics avatars by using, of course, we need to use a lot of robot technologies and AI technologies. We need to make it more autonomous, or but of course, we don't need to have a perfectly autonomous robot. So robot need to follow the human intentions. So that is the avatars. If avatars, they can follow the operator's intentions in many levels from the very low level to the more abstract levels. So avatar can help us very much. And we can, so if I dive into the avatars, I can be in Australia and I can work in Australia. Of course, the same things happens for you, right? So if you use avatars, you can come to Japan easily. Right, so that is our features. So we need to develop that kind of features by developing avatars by using the robot and AI technologies.
Thank you. We'll talk about avatars a bit more later. Michael, could you step in now?
I guess more broadly, a couple of the things that Australia and Japan share in common is that we have, on a global scale, relatively small populations, and through fantastic health systems and other aspects of our societies, we have aging populations, which has already been mentioned. And so the proportion of the society that is capable of doing unskilled and skilled labor across all domains is gradually reducing. And so there's this great need for what you'd, I guess, call a force multiplier. So robotics, AI, and automation that enhances the throughput of the workers who are working so that we can meet the demands of society across care in terms of industry and so forth.
Thank you. And Keiko?
Yes, as already everyone indicated, so labor shortage is a very severe problem, both in Australia and in Japan, and especially in the field of nursing care. So especially in Japan, it is a very severe problem. So the robotics could provide some solutions, I think.
Thank you, Keiko. I'm going to ask Nicole. You mentioned robotics addressing labour shortages. Can you tell us a bit about your startup deploying robots in agricultural settings, and what are the drivers for this, and are they similar in Japan and Australia?
Yes, of course. So I've been working on Lyra Robotics for quite some time now, and we're involved in using intelligent robots to help strengthen the food supply chain through automated picking and packing of different kinds of fruits and vegetables and other food type products. So what we're seeing is that there are a substantial amount of labour shortages, and there simply aren't enough people to be able to fill these roles. And when there's not enough people to fill these roles, it causes a lot of tension on the food supply chain. It's harder for fruits and vegetables to get through when they're fresh and when they're at their best. And it causes a lot of difficulties with trying to get different types of fruits and vegetables as a consumer as well. So really in labour shortages, there's two types. There's both the scarcity and the turnover. In Australia, it's been quite, there's the use of transient labour in these types of tasks, and in Japan, an ageing and declining population. So really, there has been also population decline across both Australia and Japan. The average age of the Japanese farmer is around 67 years old, and in Australia around 56. And there aren't younger people that are taking up these types of roles to enable a steady and secure food supply chain. So there's not enough people to perform the work. And then when there are people, there are still turnovers, quite a large volume of turnover in that work as well. So really what we're seeing is that there's a lot of investment, as well as the number of deals that are happening for new agri-tech investments, both across Australia and Japan, for enabling food self-sufficiency with the volume of food imported into Japan, but also Australia to maintain its role as a key exporter in providing fruits and vegetables to other countries and areas as well. So we're seeing a very big drive towards wanting to adopt more machinery and automation in robotics in the agri-food and agricultural spaces, as helping to support these businesses and to ensure that fruits and vegetables are going through the supply chain and able to get to consumers on time and in a state that it's ready to eat.
Yes, I was especially conscious during COVID lockdowns, and also when people couldn't travel, we did have a big shortage in agricultural workers. So I'm going to ask Keiko the next question. Keiko, You've been involved in developing robotic care devices, particularly devices to help nurses and carers. Can you tell us a bit about this and also your research on safety issues with assistive robots?
Yes, I have been involved in several projects regarding robotic development of robotic care devices since 1913. So two ministries in Japan, Ministry of Trade and Technology and Ministry of Healthcare, so that means METI and MHLW has decided to set a priority area to put the robotic technology in the field of care. So that project I involved was aiming to develop such devices in this field. And I'm not involved in the development directly, but I was the member of the consortium to establish criteria for evaluation of such robots. And mainly, I was working on safety issues. And safety of the robotic care devices is, sorry.
About the safety.
Yeah, so we have to pay special attention on safety issues on robotic care devices, which is one which would be regarded as an assistive robot. And the reason is that so the user of that kind of robot are not familiar with machine safety, and those robots are applied to the elderly who are in need of care. So what to say? So very weak people. So we have to pay special attention on that.
Yes, my mother's in aged care and I'm very conscious of these issues. And I noticed they have these wonderful devices to help them, and it would be very helpful if some of them could be in the form of robotics here.
Yeah.
So thank you. So my next question will go to Hiroshi. So when we talk about using robots or avatars in healthcare settings, the way it looks must be important. So Hiroshi, can you tell us what the benefits and drawbacks are to having a very realistic human-like robot to interact with people?
Well, I think it really depends on the patients or the elderly, the people's preference and the situations. And basically, the human, we have our brain that recognize humans. Therefore, if we consider the ideal interface for the humans, I think, machine need to be human-like, and the machine need to have a human-like appearance. So that is much easy for the interactions. But the honestly speaking, the elderly and the maybe young children, they don't like to interact with a very, very human-like robots like my Android. They prefer to interact with cute or non-character neutral the robots. They want to prefer to choose that, right? But if we want to use the robot for for example, the receptionist or some, on the public places or some formal places, it's better to give a very human-like appearance, right? So, so my answer is according to the situation and the purpose, we need to choose the human likeness for the appearance. right? And so well, especially for the elderly care, I think we can just use the character-like robots or neutral design robots.
Yes, it's interesting though. You did say that children and elderly people prefer non-human-like ones. So yeah, I find that surprising.
Actually, we are running a lot of field tests, and then for example, the autism kids cannot talk to the humans, but they can talk to the the robots. And of course, if a robot is so human-like, they don't like to talk with an android, right? The similar things happens for the dementia people. Right, so their responses are very similar, but important things is that to give a more human-like robot to the autism kids, it's a training phase. So we can start from the very simple, animation character-like robot, and then we can replace with a more human-like robot. And finally, we expect the autism kids talk with the real humans. So that is our challenge.
Thank you. Hiroshi, you've said before that you build robots because you want to understand humans. Can you tell us what you've learned about being human from designing a robot that looks just like you?
Well, we can learn many things, right? And basically, we need to do the two things. One is the scientific approach for understanding humans, and then we can improve the robot performance, right? So, and we are learning the many things by creating the very human-like robot. Well, for example, which factor is important for the human likeness? Eye movement, head movement, and gestures, right? So, and if we have a very human-like robot, we can compare the real human and the robots, and then we can control the many factors of the robot, and then we can identify the important factors for the human likeness, for example, and then we can use that knowledge for improving the robots.
I'd love to see one of your robots, but we'll have to leave that for another day. Oh, yes, thank you. Thank you. Well, could swap places. Yeah, thank you. So talking of using avatars or very lifelike robots, there's going to be a lot of moral and legal questions that researchers must deal with. Michael, from your work around the world on the impacts of robotic technologies, what do you think are the biggest concerns or challenges, and what might we worry about unnecessarily?
Sure, this is a really important issue, and we can't go through all of the issues in a short sort of discussion like this. Two of them really revolve around privacy and cybersecurity and the concept of what caring actually means. So one of the real use cases for these robots is providing dignified care for all sorts of sections of society, and these would be robots that would be interacting with you in some of your most, I guess, vulnerable moments. And so the bar and onus for privacy and security of that interaction is perhaps especially high compared to maybe a robot you might interact with at the shops. And so it's vitally important that we make sure those problems are solved satisfactorily. I guess what people perhaps worry about too much in that case is they imagine or envisage, or some people do, that we have to solve these problems from scratch with robots, when there's been a lot of very good foundations around privacy and security in other technological areas. So smartphones would be a fantastic example of this. Smartphones are not robots by any means, but they share a lot of the same characteristics. They can listen to you, they can watch you. And so some of the problems that robots in, for example, care settings will need to solve around cybersecurity and privacy have very good foundations of solutions in other technological areas. And so we need to do a lot more work in this area. People are doing this work, but we're not starting from scratch. So it's not the insurmountable problem that I think has sometimes been portrayed in, for example, the media. The second, I guess, deeper, more philosophical question is this concept of care. So can a robot, an autonomous system, or even an artificially intelligent agent genuinely care for someone? Now, you can answer that at a superficial level really easily. A robot could technically do simple things like feed someone, wash their face with a cloth. That's definitely technically achievable, or will be technically achievable. So in terms of the concrete instantiations of some aspects of care, the robot can care for a person. But at a deeper level, there's this sort of more philosophical concept of, can a robot or artificial intelligent agent actually care for a person? And this is something that I think is still quite controversial, and something that's, I guess, a subject of ongoing discussions. So for basic practical aspects of caring, sure, the robots can do it. But to what extent do you still want people in the care loop? Perhaps because you think that people are uniquely capable of some higher level aspects of care that an artificial agent might not be able to do.
Yes, and I've enjoyed a few movies where they discuss those topics. But Michael, you've also been working on creating better navigational technologies. How will they help our societies, and how are you incorporating a focus on privacy into these technologies?
So everything that moves, whether it's a person, an animal, or a robot that we're building, it needs to know where it is in the world, and it needs to know how to go places in the world in order to do any of a number of tasks. It could be a drone, it could be a robot, it could be a care robot or a hospital robot. And so we work on a lot of the foundational mapping, navigation, and positioning technologies that will give both machines like robots and people the ability to know where they are and to be able to navigate very effectively. We currently rely on systems like GPS, so the global positioning system that comes from satellites. This is a fantastic triumph of technology, but it doesn't work everywhere. It doesn't work underground, it doesn't work indoors, and there are potential situations where we may not have GPS always available to us. And so coming up with alternative systems that complement and provide some redundancy to GPS is a major focus of our research. Now, no technology is useful unless society accepts it. And we've seen, especially more recently, massive acts of, I guess, data breaches, hacking, and they really compromise the effectiveness of a lot of technologies, because if you're worried about all of your data being leaked, then that's a major concern, and you may not deploy the technology in the first place, which is a tragedy. So one of the approaches we're taking with this navigation technology that we're developing is really what you call some level of privacy by design. So we're designing the whole technical approach to these systems to, for example, inherently preserve visual privacy. So if this is a camera-based navigation system, the information that the so-called camera acquires and stores will be so obscured and coarse that there's really no compromising visual information. So even if someone hacks the system, and ultimately all systems are hacked at some stage, it's something that you pretty much can't prevent, we'll be able to minimize the amount of sort of compromising information because inherently the system doesn't have any. And so that whole privacy by design focus is a big part of what we're doing.
Thank you, Michael. Now we're going to move to Keiko. Keiko, you're also involved in a program promoting healthy living among the elderly. Do you hope this will reduce the amount of care that people eventually need? And can you also tell us about the international collaboration aspects?
Yes, so before answering your question, I'd like to add additional explanation about the robotic care devices. So it is not full robot as Michael concerned, but it's like a ordinary device with sophisticated control. But anyway, so to use, develop and make it in the market, and when people are using, then we need money to purchase it. So it may be purchased by personnel or by government. We need money to do so. So now in Japan, so larger budget spent for elderly care and medicine are also another issue. So the easiest and so most happiest way to solve the problem is to, well, make as many people as possible to keep their healthy living as long as they can. So I'm also involved in the program to provide virtual coaching to motivate healthy younger elderly people to well, keep their health. So this kind of issues are also European countries have same situation. So now we are having collaboration studies between Europe and Japan, so-called VITA project. And so that project investigating the virtual coaching system using robotic and AI, and also the knowledge of clinical studies.
And it'd also be good for Australia to collaborate in such studies, especially as our population is aging as well.
Yeah, I hope so.
Yeah, thank you. So Michael and Nicole, at the current rate of research and development in Australia, do you see robotics keeping up with our pressing societal challenges like aging populations and worker shortages? So,
look, these are massive problems, very much at the forefront of everyone's minds. Aged care in both Japan and Australia are, I guess, topics of strategic concern, and there are no easy solutions as far as everyone can determine. They're also incredibly difficult problems to solve. The technological component of creating robots and other technologies, it's not just robots, of course, that can sufficiently solve these problems is incredibly difficult by itself, but then it has to be integrated with all of the other disciplines, so human factors, societal concerns, economic concerns, and so on. One of the challenges that commercial interests, so large corporations and companies, are very well resourced, almost infinitely resourced, but are perhaps not as well motivated to solve these problems because of the perception of risk, the challenge of the problem, and maybe the perception that there is no short-term, or it's risky in terms of short-term commercial payoffs, and they're commercial companies. That's what they do. One particularly relevant example, which illustrates how hard this challenge is there's been a lot of news about the Amazon Alexa device, for example. And this is a very relatively simple device that sits in your home and by all accounts has been not remotely commercially successful. And then you extrapolate that to a physically embodied robot that's doing far more complicated tasks in the home, and you get a sense of the magnitude of the challenge. Japan and Australia, in terms of research and development, they definitely already and are well known for punching above their weight in terms of research capability in areas like robotics and AI. But given the magnitude of these societal challenges and the extreme difficulty level of these technical challenges, that is not enough in of itself. One of the major things I think is needed, and this is just my opinion, is we really need strategic grand challenge initiatives and investments that don't occur at a university level, that don't even occur at a country level, but really occur at a global level with consortiums of countries that have similar interests, for example, Australia and Japan. And only then are you actually going to, I think, have a reasonable chance at making a substantial advance in some of these critical areas.
Thank you. Nicole?
When it comes to the all-purpose generalized humanoid robotic, clearly there's a lot of additional research and development that needs to occur for one simple machine to be able to do such a broad variety of pressing societal challenges. But when we look at smaller components of highly effective robotic applications that are specifically designed for one very well-defined task, there is the opportunity for robots to deploy in these types of spaces. So if we look at individual tasks rather than the entire composition of what would be considered the job, then there is good product market fit in certain areas that will allow robotics to be introduced sooner and to start having greater effect in society right away. And then once we further come along, as Michael said, with more research and development in larger spaces and groups, can we then start to add a variety of these different types of robotic tasks together to make something that is more generalized for a particular area or a particular space that could benefit from having more robotics deployed in that area. So really, I see robotics will catch up if the designated task of the robot is specific and reliable enough to work in a dynamic environment. And then it will just be addressing edge cases and being able to expand and broaden the applications into different spaces in future.
Yes, and of course, being able to use robots in dangerous situations is a useful thing from the human point of view. Yeah. Nicole, I'd be interested in your thoughts on what we in Australia can learn from Japan, which you've mentioned is a lot more advanced in having robots in social spaces. Although I'm starting to see them occasionally in a restaurant, but all they do is take your order. Thanks, Nicole.
Yes, so it's really interesting to see in Japan, you're just much more likely to see a robot in a public space or in public-facing roles. There's just been much more long-term exposure and familiarity with their use, and therefore the acceptance of having robots in shared spaces with people, which then leads to further deployment and application cases of designing robots for other types of tasks, whether it's in hotels, restaurants, museums, other types of public spaces that you might visit on your average day-to-day. So in Australia, we don't have as much visibility when it comes to robots in public spaces. So I think there's a fantastic opportunity for Australia to look to Japan to work out ways that we can deploy and to be able to create greater acceptance in communities for robots being in and around people. Because really, if we can't have people accepting robots in and around them, how do we use robotics to address some of these pressing societal issues, such as having robot support, as Michael mentioned, aging populations? So what I'd be interested to see, and through more research and collaboration, is how we can follow a similar curve to help speed up the deployment of autonomous robots in and around people, so they lead to more successful deployments and then therefore more deployments, and robots can have a greater impact in different types of human spaces and providing tasks and support in areas that will improve human quality of life for a large population of people.
Excellent, thank you. Hiroshi, you mentioned you're involved in the Japan Science and Technology Agency's Moonshot program, and specifically you're managing a project to create a human avatar society by 2050. The words freedom and inclusive come up a few times in the project description. Can you tell us about it, please?
Well, our purpose is to extend the human abilities by developing the robot avatar and computer graphics avatars. If we can use the robotic avatar, as I said, we can just stay at home, but we can work in real times by using the avatars. Right? This is a pretty good system for the elderly. So, and we're gonna have a labor shortage, but therefore, elderly need to they keep working, right? And if we provide avatars, so that's possible. And then, the handicapped people, right? And they want to have that more freedoms, and they want to use the avatars for workings. So recently, last year, I started my venture companies with computer graphics avatars, and then we're working with the convenience stores. Convenience stores is going to be the autonomous. They are using autonomous cashiers, but it's impossible to make it fully autonomous, right? So the people need to have some helps by shopkeepers, right? But if we assign the human shopkeepers, so, then we cannot solve the labor shortage problem. Our solution is to put the computer graphics avatar there, right? And we have recruited the 5 avatar shopkeepers operators, 5 operators, because we wanted to start the just one the new convenience stores with avatars. But actually 400 people applied, including the many, the handicapped people. So that is the possibility of avatars, right? We are feeling the very realistic possibility of avatar world, right? The people want to use the avatars more and more, and the people want to have a freedom to work in real societies. And then the moonshot project is to promote that kind of, our important futures by the 2050s. But 2050, I expect to use more, the sophisticated avatars with the robot technologies and AI technologies, and everybody can enhance their own abilities beyond the limitation of bodies or beyond the limitation of space and the time. So that is an ambitious goal of our moonshot project.
Yes, I'm pleased to hear about that. So I'm going to ask both you and Nicole a question now. So can you tell us a bit about the collaboration you have planned and how important is collaboration to your research? So Nicole, would you go first?
Of course. So we're looking to work together to help accelerate robot deployments for having robots in supportive roles for people. So similar to the response before, there's quite a difference in the exposure that people have to robotic systems, and therefore their willingness and level of engagement and interaction uptake in robotic systems. So we're interested to have a look at how to improve the willingness to want to work with a robot, sharing knowledge and learned outcomes between the two labs on how we can help encourage people to accept and see robots as collaborative technologies that will help them and will provide support for them in the tasks that they'll be working on together, and to see how we can use this knowledge to help accelerate the deployment of robots in public spaces, especially in Australia, when the very first interaction with a robot might be quite different to perhaps your 10th or 20th interaction, and how can we introduce it in a way that helps to keep a collaborative narrative. And if we can deploy robots, then there can be more opportunities to support people for better quality of life.
Thank you. Hiroshi.
So I'm also very exciting to have the collaboration with Nicole, and especially I'm interested in the difference, Australian people and Japanese people. What is the difference? What is the similar things? And I want to consider how we can spread the Japanese technology, robot technologies in the world. And in order to do that, we need to learn from your country a lot, and then we can have some the really international collaborations for building the robot world, or the future world supported by robot technologies. And is probably we want to compare the difference, the virtual robot, the computer graphics robot, and real robot, and very human-like robots. So we want to compare the many the several things from the different angles.
Yes, it'll be interesting to compare the different cultures and how we accept them. So, Keiko, is there an area of AI or robotics that you think is under-researched? And is there something you would love to look at if you had time?
Well, so I think many researchers have studied many areas in robotics and AI. So I think in that means, so a lot of activities are going on, but in thinking of social implementation, so we have to take another step from the research itself, I think, and so for better social implementation, so other areas such as materials and so batteries, like that kind of technology could also improve the social implementation of robots, I think. So that is so my personal interest.
That's right. Robots need power, so we need better batteries. Yeah.
Yes.
Thank you. We've unfortunately run out of time, and we'd like to leave about 10 minutes for questions. So I'd like to thank you all for your insights and expertise, but I'll just go. I saw a question in the chat from Vernon, which I'm desperately trying to find again. Oh, here it is. And it's, are there any potential funding opportunities for researchers at Australian universities to establish some collaborations with our Japanese colleagues? Now, I know there is a joint Australia fund. I'm hoping Lynn can check up on that, but Michael or Nicole, are you aware of joint funding opportunities? We do have some Japanese programs, but none of us have got them on the tip of our tongue, right? So we'll try and look that up, and we'll move to the next question, unless somebody wants to help or put the answer in the chat for us. On the topic of robots caring, this looks like this is a question for Michael from Haley. On the topic of robots caring, a big part of care is being responsive to the needs of the person being cared for. Do you think robots could have that capacity to be as responsive as human carers?
The answer to that is yes, with a lot of caveats. So I think a lot of people get into robotics. One of the first things that really captivates their imagination is the idea of robots and technologies helping care for people, helping people with vision impairments. And then the reality starts hitting them when one of the biggest challenges is the fact that care, as you say, Haley, very much needs to be individualized and personalized, not just to the specific care requirements of the person, whether it's a vision impairment, whether it's a specific disability, but also to the specific, I guess, personality traits of the person and what they accept, what they don't accept, and so forth. And so individualization and customization has been one of the biggest barriers to mass deployment of assistive technologies, including robots, across all of these areas. Now, what is promising is that in the last 10 years especially, we've had some very substantive advances in the artificial intelligence technologies, technologies like deep learning, which is a relatively new approach to AI, which uses very powerful models at a very loose level of how our brains work. It's a very simplified explanation. And one of the key capabilities of these systems is to be able to rapidly learn fairly complex tasks. And so there is a lot of potential to deploy these new AI-based technologies on robots and other assistive care technologies so that the care experience is personalized to the individual. The challenge is that these powerful capabilities come at the cost of what we would call transparency and explainability of these technologies. So they're able to do amazing things. They're able to customize their behavior to the specifics of the situation. But our knowledge so far of how they do it and what the bounds on what behavior you'd expect from them is still somewhat limited. And so there's a lot of work being done on how we can deploy these much more capable technologies in a way that's still safe and responsible.
Very important. So there's a question for Hiroshi coming up. A few companies are already using your avatars in conversational services. What are the most common problems that occur as they become involved in society?
Well, probably that is a cost, right? Basically the robot, the physical robot, the cost of the physical robot is very high comparing with the computer graphics avatars. So, I have mentioned about my venture company, the startups, right? My startup company, we don't build the physical robot first. We just provide the computer graphics avatar first, and then we're gonna establish the environment in which the people can use the avatar and can work with the avatars. And then, the people, they get familiar to work with avatars. Then we can replace the high value work with robots, right? So that kind of a step is very important, right? So in Japan, many companies, they made the big challenges. They built a robot and then they try to use a robot in many purposes. But unfortunately, they couldn't keep the activities, right? So the most important thing is applications. So how, that we need to develop the very basic applications to use the robot. So I believe that is the avatars. If, for the avatars, we can start from a computer graphics agent. Then we can replace the avatar with the robot, right? So, and this kind of strategy for the market development is very, very important, I believe.
Yes, I read an article. No, it's a news article, not a scientific one, about AI being involved in diplomacy and actually working quite well. You're getting the language, the appropriate language right. So it's a useful application. So I'm afraid we're running out of time. So our final questions for Nicole. What do you think is the most exciting thing about research in robotics right now?
Really, there are so many exciting things. We're at this fantastic point in time where robots are really accelerating to be able to deploy in really dynamic and unpredictable environments. So we're at this point where we could start seeing robots in places that we wouldn't have traditionally thought robots might be, social spaces, workplaces, in home, in the office. And the opportunity for these robots to then provide support to people directly to do other types of mundane or routine tasks, it's really going to create fantastic opportunities to use machinery in a way that hasn't really been provided beforehand. And from a research perspective, being able to combine everything we know about robotics and starting to build one robot or a selection of robot platforms that can do multiple things at different points in time, and what that really looks like for coming from the idea of science fiction of having a robot that can provide all these different tasks to people, to seeing breakthroughs once every year, much more frequently at this rate, of how that looks like and getting much closer to having that as a reality. So it's a fantastic time to be involved in the robotics space, and there's always a lot of exciting things happening in terms of making robots a reality.
Yes, that's right. Thank you very much, Nicole. So we've come to the end of the time, and it's been a fascinating discussion. I'd like to thank our expert panelists for their engaging responses and insight into the fascinating world of AI and robotics. As we've heard, there are many opportunities for Australian and Japanese researchers and entrepreneurs to collaborate, and we'll look up the grants that are available and help solve some of the most pressing societal issues with their cutting-edge AI and robotics solutions. Thank you to everyone who tuned in today. We welcome you to join us for the second event in the series focused on health research and technologies, same time on Thursday, the 8th of December. Go to the Academy's website for more details or scan the QR code on screen now to register. Thank you once again for joining us today, and have a wonderful afternoon. Bye.